Road to Olympiad.
Welcome to RTO. Consider the following problem. Let A1, A2 until AM be a sequence of real number. Define Q sum as the sum of Q consecutive term in the sequence. If every 7 sum in the sequence is negative, whereas every 11 sum is positive, find the greatest possible value of M. This is a pretty straightforward question where we can directly list out some 11 sum and look for 7 sum from it, or vice versa. And we should be able to find some contradictions when it comes to certain value of M. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by listing out a few 11 sum, which are all positive. Upon listing 7 consecutive 11 sums, we can find a 7 sum here when we look at a column. In fact, each column in the sum we listed here is a 7 sum, and they should be all negative. In this case, we have a problem here. Viewing horizontally at each of the 11 sum, the sum of all the numbers here should be positive. However, when we view vertically at each of the 7 sum, we find out that the sum of all the number here is negative instead. Thus, we reach a contradiction when there are 17 terms. In fact, the same problem will occur when we have more than 17 terms, as we can always find a subsequence with 17 terms that leads us to the same contradictions. Therefore, the maximum possible value of M here is 16. Next, we need to show that M is equal to 16 is actually achievable, which is to say that there is a sequence with 16 terms with the above properties. Down here we give one possible such sequence. We can check that in this sequence, every 7 sum will be negative 1, whereas every 11 sum is equal to 1. And thus, this marks the end of our solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.